5G mobile phone technology is finally with us. It's live across the UK with increasing coverage. 5G is meant to bring us super fast broadband, control of driverless cars, drones, remote robotic surgery, holographic video calls, and no doubt other applications. Right now though, we continue to use mobile devices as media hubs. We create, post, download and stream all media forms to and from social media services like Netflix, Amazon Prime and YouTube. Netflix recommended download speed of 25 megabits per second to stream 4K ultra-high def programs and films. In addition, the average broadband speeds in residential properties in the UK in 2019 is 54 meg download. So is 500 megabits per second, even gigabits per second speeds that 5G touts really needed? Isn't 4G good enough? Do we really need it now, and should you go out and upgrade? To answer these questions, I'm going to take a nostalgic look back at my personal collection of mobile phones from 1995 through to 2019, selecting a small number of key models, attempting to resurrect them after years of doing nothing, with the aim of testing their ability to access the internet, the download speeds they can achieve, and how the different technologies fare in today's media-centric world such as media browsing and streaming. To narrow down the best models, I've chosen ones from approximately every 3 years, and the latest tech at the time, from 2G and its upgrades, 3G and its upgrades, all the way to 5G. I excluded other models, including the T68i, Nokia 5.1, Orange video phone and such like. Of all my collection, I chose these ones, but later excluded the Nokia 6150 as it couldn't be used as a modem. The Motorola 3200. Released in 1995, it was the first hand-portable 2G GSM phone in the UK. Classic brick style, and this phone still works and can make calls on it, albeit the battery doesn't last long now. In a moment you'll see a call being made from the latest 5G phone to this first handheld 2G phone. Old tech is still alive. The Nokia 6210E, released in the year 2000, a very popular business model supporting an upgrade to 2G called HSCST with a maximum speed of 57.6 kilobits per second. It's capable of being used as a modem for basic uses such as emails. Supporting a slim design, it had an infrared communication port as Bluetooth wasn't prominent back then. The Orange SPV E200, released in 2003, the second version of HTC and Orange's phone running Windows Mobile, and the first proper smartphone in my opinion. Visionary in fact. Colour screen, camera, Windows feel to it, Internet Explorer and basic versions of Orange apps. Supported what's known as 2.5G or GPRS Class 8, download speeds maximum 86.2 kilobits per second. The Nokia 6680, released in 2005, one of the earlier 3G phones from Nokia, which also supported 2G Edge as well as the first version of 3G with a maximum speed of 384 kilobits per second. Again, an improving camera design with flash, expandable memory and a colour GUI. You can see here a 3G connection on EE loading up a basic mobile version of the Google homepage. At home I was also getting over 300 kilobits per second. The iPhone 3GS, this needs no introductions, an absolute classic design. This is the advanced 3G version from 2009, supporting what's known as 3.5G, technically HSDPA, with download speeds maximum 7.2 megabits per second. This iPhone heralded the beginning of smartphones as we know them today, but also the demise of Nokia. Up to this point, all the phones varied a lot in size, design, style, but from this point on, from 2008 to the present day, all phones are essentially the same. The Samsung S3, released in 2013 and the first 4G model using Android's Ice Cream Sandwich operating system. It can support download speeds of a maximum 100 megabits per second. This is a technical testing model with TEMS software that I used extensively back then. It was also around this time that Samsung overtook Apple with phone sales, in terms of revenue anyway. Samsung S6 Edge released in 2016 with Android's Lollipop operating system and with LTE Advanced supporting download speeds maximum 300 megabits per second. Finally, the Samsung S10 5G, released in 2019, Samsung's first 5G model, with also LTE Advanced Cat20 and 5G NR with speeds in excess of 2 gigabits per second download and 150 megabits per second upload. Setting up these phones has been a challenge. All mobiles always had their own chargers and not common types like we have today. Having found and sourced these, and since a lot of them haven't been touched in years, batteries either didn't work or don't hold their charge anymore. You can see here how old batteries have expanded or warped. In the case of my iPhone, the battery had expanded and caused the back casing to crack and the screen to come loose. As a result, I needed to source new batteries for quite a few of these phones, or even a replacement phone like the iPhone here. Pretty much all of my earlier phones were on orange and SIM locked, which was standard for a long time. Consequently, some phones needed to be unlocked, either with codes that you can get online or via the mobile operators directly. Unlike these days, where we have mobile hotspots all set up on our smartphones with Wi-Fi, back in the day there was no Wi-Fi, and in earlier phones no Bluetooth either. These older phones needed to be tethered using cables or an infrared port. The Nokia cable shown here is an obsolete one, and even with a USB adapter wouldn't work. An IRDA to USB device that I got off eBay worked with no problems, shown here a dial-up internet connection via O2. So, having charged the phones, unlocked them, established a connection to a laptop, I now had to configure them as modems. This has been the hardest and most frustrating part of the whole project. The SPV here in particular was a nightmare. Internet connection failed most of the time with a variety of modem errors. Googling saved the day, of course, here showing the manual setup of the GPRS APN settings. An old version of Nokia PC Suite made this relatively simple for the Nokia phones, as most operators have their APNs already included. E just needed manually adding. The idea here was a basic look at how fast we can get these museum pieces going. So, speed testing. Ideally I needed an application that all devices could access, common to all. I settled on fast.com, although Oculus Speed Test was also used. Web surfing, simple website loading, I chose the BBC News homepage of the time. Media streaming, simple streaming and downloading media from Netflix and Amazon Prime Video. For speed tests, we generally visit online sites like speedtest.net or fast.com. With slower internet connections, however, this isn't the best solution, as the website has to load as well as do the test, which can be very intermittent as they time out. This was an example of such an experience with the SPV E200. Time out, but then successful. This can be overcome by running equivalent command line interface terminal versions. However, I found that even these command line versions tended to need a decent internet speed in excess of a megabit per second to function properly, otherwise you get a common check your internet connection error or timeout again. This timeout problem also affected streaming platforms like Netflix. Even though you get to the point of buffering an episode, it can fail with an internet connection problem. So the only way to test that an internet connection actually does exist with these old phones is to perform file transfers. My own cloud storage, if you like. This can be done by setting up an FTP server on a home PC and an FTP client on a laptop doing the testing. Doing this required FTP ports opening on my broadband provider Virgin Media's router and firewall rules adding to my Norton security software. I used the FileZilla and CyberDuck software for the file server and client for the file transfers themselves. Some older smartphones app versions are no longer supported by the developers, such as Netflix here, and screen recording software for this video, so even though the phones originally had apps that I could have used, I now have to tether and use PC versions and screen mirroring software like Mobzen for recording the action, shown here mirroring the Samsung S3's display. Firstly, the Nokia 6210E. Unfortunately, I didn't record the testing of this phone. I'd got everything working, internet access, speed tests with FTP sessions, averaging a speed of about 8 kilobits per second. But then, when I tried to record it all a few days later, it seemed that circuit switch data had been turned off in the meantime. Typical. EE had disabled it some time ago. 3UK of course doesn't apply. Vodafone had just disabled, like I said, and although O2 was allegedly still working, I couldn't get it to, as you can see in the video. Now I complained to the head of Vodafone Networks, but that just didn't work out. Nonetheless, like I say, speeds of 8 kilobits per second or 8 thousandths of a megabit per second download, which would take about 28 minutes to load a typical website. Nice. the orange SPV E200, we can see here the internet connection via Bluetooth with additional configuration requirements for the GPRS dial-up connection. For the speed tests, there is a failed fast.com attempt, followed eventually with an example of a completed one at 40 kilobits per second download. The command line versions also showed errors or would time out, highlighting the uncertainty of whether there was an internet connection at all, although the network icon in the Windows notification area highlights that there is. Onto the FTP file transfer of another 700 kilobyte photo, this time using FileZilla, starting at real-time speeds here, but we'll fast forward through and eventually complete with an average download speed of 43 kilobits per second or 0.04 meg. When the upload of the same file was completed after 641 seconds, the average upload speed was 9.5 kilobits per second or 9,000ths of a megabit per second. When trying to load the BBC News website, you have to remember the difference in file size depending on whether you're loading a cached or non-cached page. In my case it was the smaller file, but even so it still took 90 seconds, which would be about 8 minutes for a full website. Imagine today's web browsing taking 8 minutes for each page to load. Needless to say, streaming Netflix was not tried, it would simply take too long. For the Nokia 6680, here we have it connecting to the internet via the Nokia PC Suite software. For the basic speed test, we get 150 kilobits per second download, 130 kilobits per second upload. This Nokia is also the one I tried the Oculus speed test web version, and as mentioned earlier, this can time out due to slow connection. The fast.com CLI version gave us similar results, and the speed test CLI times out again, for the uplink anyway. For the FTP file transfer, I used CyberDuck for this test, a small picture file example, and in earlier stages upload speeds matched download speeds quite well. Overall though, the download was quicker, obviously. Here had an average 121 kilobits per second download and 58 kilobits per second upload. Loading the latest BBC News website of the time took 28 seconds. As for streaming, that was an experience. I could still load Netflix, but of course everything took a long time. Not just to load the login page, but when selecting the program of choice and to start the streaming itself. 2 minutes of buffering just to get here. This, however, was as far as it went. The continual circle indicating buffering of the video went on ad infinitum. It took so long that I just cancelled it. So next we have the iPhone 3GS connecting to the internet here via a Bluetooth access point. Firstly, the fast.com speed test, here achieving 1.1 megabits per second download and 390 kilobits per second upload. The command line versions of the speed test achieved speeds in the same ballpark. In the second test, loading the latest BBC News website took only 8 seconds. Onto the FTP file transfer using FileZilla and the same small picture file as before. The progress bar isn't the best updating for slow uploads, I found, almost appearing to have stalled as it shows here for the file upload. Overall though, 1.2 megabits per second download and 263 kilobits per second upload were the speeds achieved. A larger video file also achieved an average of 1 meg download. Attempting to watch Netflix on the laptop rather than the app, using the iPhone as a tethered modem, was a slow experience. It took over half a minute of buffering to start playing this episode of the Dark Crystal Age of Resistance, but having done so, it seems to play pretty smoothly. It's actually possible to stream using this 10-year-old phone.
Another world.
But try jumping ahead and there's again a large delay while it buffers, but it does continue eventually. It's not bad for such an old phone and technology, with a speed of only 1.2 meg. So next we have the S3 engineering version. Firstly, the fast.com speed test, here achieving 17 meg download and 3.4 meg upload when tethered on the laptop, but only 13 meg using the phone. So onto the FTP tests, using CyberDuck software this time. The picture file achieved an average of 6.7 meg download and 4 meg upload. I didn't test for loading the BBC website, as at these speeds it would have been less than a second anyway. Onto the video streaming, and I've synced the playback start on the laptop and the phone. On the laptop, Netflix previews and the playback of West Coast Customs starts quite quickly with a little buffering. On the phone app, however, attempting to stream Carnival Row, there's quite a lot more buffering before the playback commences. On the laptop, if you fast forward, there's still a few seconds of buffering before the stream continues. On the phone, however, the playback is not smooth, clearly some buffering going on or app issues, hardly a usable experience. Now, I can't say whether this is due to radio coverage conditions at the time. These results go along with Netflix's recommended speed for decent quality streaming, so again this is on the verge of usable. From the S6 onwards, we can just record the apps themselves, as all the apps needed for these tests are supported on the Android versions. Fast.com speeds here achieving 55 meg download and 3.7 meg upload, latency of 35 milliseconds. On a later set of tests that I did using Vodafone, which is shown in the background here, the S6 achieved speeds of just shy of 100 megabits per second download, 30 meg upload. This is a fantastic result really. Using Amazon Prime to stream Mr. Robot here, it took only 2 seconds to start streaming the advert at high quality, after which the episode continued. When I fast forward, there's a 3-second gap of buffering before play continues. Everything we want from a 4-year-old phone. Finally, the Samsung S10 5G. Here I'm more interested in how the 5G on Vodafone was and how it compares to 4G. Here there are 3 speed test examples, the best being a peak of 540 megabits per second download and 19 megabits per second upload. The next set of tests were to download media from a streaming platform, comparing the phones and technology download times. For this, I downloaded episodes of Absentia from Amazon Prime Video. Tests were done in 2 locations at Media City and Manchester, the second purely to get some decent results for 5G, as we'll see shortly. So there are 4 download examples. On the far left is the Samsung S6 Edge from 2016 on 4G. On the middle left is the S10 on 5G. On the middle right is the S10 on 5G in that second location, so that's the best results you're going to get basically. And on the far right, the S10 locked to 4G in that original location. So we've zoomed in on the download progress here. The fastest to complete is the S10 on 5G, that's a specific location remember, so that's an example of the best you're going to get basically. That completed in a time of 31 seconds with an average speed of 113 megabits per second. The second to complete was that 4-year-old Samsung S6 on 4G, which took 42 seconds with an average speed of 84 meg. Very good result really for such an old phone. Third to complete was the Samsung S10 locked to 4G in that original location, that completed in 60 seconds with an average speed of 57 meg. Then the S6 on 4G downloaded the second episode, with the second best quality remember, and that downloaded in 44 seconds with an average speed of 42 meg. Now that's a very similar time to the first episode, which was downloaded at the higher quality, which kind of implies that either the app downloaded at the best quality irrespective of what I've selected, maybe that's a default or something, or the network tried to maintain the maximum speed. Either way, that doesn't really matter. What matters is the fact that that 4-year-old phone on 4G downloaded 2 episodes in half the time it took for the latest phone on 5G to download a single episode in that same location. We can still see here it's still downloading and I'm just trying to fill in the time while we watch it in real time. Okay, so finally the Samsung S10 on 5G in the original location does complete the episode download in a time of 2 minutes and 39 seconds at an average speed of 22 megabits per second. So what that shows is that 5G can download a high quality 4K ultra high def episode in a super fast time, 30 seconds, and yet it can also be the slowest. A bit of a gamble really. Yet a 4-year-old phone on 4G is almost as good. So it begs the question, is it worth upgrading just for that 10 seconds quicker? So now for the results. If we compare each phone's download speed against each other, we can appreciate where the tech has moved in the last 25 years. The SPV here on orange using 2.5G packet switch data is way better than the circuit switch 2G tech of the Nokia 6210. When we add 3G in the form of the Nokia 6680, you can see how even the first version of 3G, so-called Release 99, was a great deal better. Add on the 3.5G HSDPA capability of the iPhone 3GS though, and the numbers start looking slightly more modern, with speeds in megabits per second rather than kilobits per second. With 4G though, the increase in speed is huge and leaves all previous tech in its wake, almost meaningless. The S3 averaging 16 meg as opposed to the 3GS's 1 meg. This might seem great, but 4.5G or LTE Advanced, shown here with the S6 Edge, is another leap forward. The average here is pretty much the same as the UK's average broadband speed of 54 meg. But then we add on the latest 5G with the S10, and again it's a whole dimension better for peak speeds, 10-fold increase, albeit this was tested at Vodafone's main 5G area of Media City and Salford, Manchester. You'd expect the best there. Quick look at the peak upload speeds, not that much of a difference really between 4G and 5G. What is more interesting to my original question is when we simply compare the best each generation of mobile technology gives us now, by locking the S10 to 2G, 3G, 4G, so we presumably get 2G Edge, 3G HSPA+, LTE Advanced and 5G. This is the comparison here, and I've added in what Netflix advise we need to stream 4K ultra high def content on their platform. Can you remember what it is? Well, it's 25 meg. So 4.5G LTE Advanced gives us 8 times what we need for the best quality media content, and 5G well over that. So again, do we really need 5G? Looking at a timeline, 2G with my old phones from 95 to 2003, 3G with my phones to 2009, 4G with my phones to 2016, and finally 5G with my S10. My results show that pre-2009, video streaming, web browsing, social media etc. is simply not possible. No surprise there though, that's what you'd expect, this was just a bit of fun. Between 2009 and about 2012-ish, the tech existed to support all of our multimedia needs, that is 3G HSPA and when networks had sufficient network coverage and capacity, but by today's standards it's not holding its own anymore. We saw how the iPhone 3GS performed, it just managed to stream the Dark Crystal Age of Resistance from Netflix, and for a device over 10 years old, it highlights again what a great product it was, so all respect to Steve, he sure did a great job with it. Since around 2013 onwards, but certainly by 2015, the tech has supported our multimedia and social media needs as we know them today. Nothing fundamental has changed since. So in conclusion, pre-3.5G phones have been a pain, but they're still a bit of fun. 3.5G phones of yesteryear still manage to perform admirably today and perform all the functions we use these days. 4G is perfect for what we use phones for today, from a media perspective anyway. The Samsung S3 or the S6, around 5 years old now, do everything we still want. 5G's benefits require a wider area of coverage to be seen. Sadly, Vodafone's is a bit of a joke at the moment. So, to answer the original questions, 5G is not needed for mobile devices. Not yet, that is. 4G is easily good enough. If anything, with some networks, you'd be worse off with 5G. This is not unusual at the start of a new tech release. There is no point upgrading to 5G now, there's just not too much of a benefit, unless a matter of seconds matters to you. But what we do need right now though, is a new vision for the next thing for mobile phones. It was 1979 into the early 80s when Martin Cooper developed the first hand-portable mobile phone. His vision of widespread use of mobile phones, however, didn't come into fruition until about 1995 with 2G GSM. It was around the year 2000-2002 when the next change in vision occurred for mobiles. That multimedia vision and its potential wasn't realised for another 12, arguably 15 years, and took 2 generations of technology to realise that vision. I don't know what the vision is for 5G mobile devices, but if 40 years of mobile history is anything to go by, that vision won't be fully realised for 10 to 12 years easily, and will need 6G, maybe 6.5G to be commonplace. So don't expect widespread holographic calls to be common until the year 2030 to 2035. Okay, thanks for watching everyone, I hope you enjoyed it. If you did, please do the usual stuff, press like, subscribe as there's more videos to come, please leave some comments and I'll reply to more.